Hi, now this is a video on how to produce a round-robin matching schedule for n number of teams, and the sport that we're going to be talking about here is football. Now, as you may or may not know, football is a sport that's comprised of home games and away games. Now, home games essentially just represent games that are played on your own turf. Away games represent games that are played away in a different region or in a different country. And in the context of this characterization, we are going to denote home matches as H, away matches as A. Right. And now, based on this knowledge, we're essentially able to produce a sort of pattern for whether a certain round for any team I is played at home as a home match or an away match. Say that we have team I, and team I plays a number of rounds. Let's say that it plays 4 rounds. And let's say that round 1 for team I was a home match. Round 2 was an away match, so on and so forth. And we know that team I is going to have to play n-1 matches, right? Because we're producing a round-robin matching schedule. Round-robin essentially means that you're playing every single other team. And because we have n teams, we know that it's going to play n-1 matches because it can't play itself. But it will probably play all the other players or other teams. So we're going to have n-1 matches. And for all n-1 rounds, we're able to assign each round a letter based on whether that round was a home match or an away match for team I. So based on this, we're able to generate a sort of a sequence consisting of letters H and A's, representing whether that round for team I was a home match or an away match. And we're going to call this sequence a home-away pattern. Now, consisting of home-away patterns, consisting of n home-away patterns, because we have n teams, is going to be a home-away table. Now, at this point, I think it's a good time to kind of introduce the concept of breaks and the conditions that we have in terms of actually generating a round-robin matching schedule. Now, if we have 2 consecutive homes or 2 consecutive aways, we're going to call that a break. So if we have 3 H's lined up, we're going to call that 2 breaks. Conversely, if we have an A and an H together, this does not count as a break. This is not a break. So it's when we have 2 letters consecutively together. And that's when it counts as a break. And some of the conditions that we need to kind of adhere to when generating a round-robin matching schedule is that, firstly, we cannot have 2 consecutive breaks. So we cannot have a schedule wherein we have 3 home matches consecutively and 3 away matches consecutively, or even more than that. So the maximum number of away matches or home matches that we can have consecutively is 2, i.e. 1 break. And also, for any round I, the number of A away games and H home games must be the same. This is because on the basis that we have n teams, and we know that n teams is going to be an even number because it's round robin, and so you need to have a competitor within that n team. Let's say that we have teams A, B, C, D. If A plays B and C plays D, and teams A's and C's essentially just played an away match, and B's and D's, they played a home match, we can see that the number of A's and H's is going to be equal for any round I. So that is some sort of condition that we have to meet. And in order for us to adhere to that condition, it's good to produce a sort of an equation and make sure that in any scenario of generating a round-robin matching schedule, we keep adherence to that equation. And so to understand how that is, let's look at this sort of table that introduces this idea of calculating a minimum for the home and the away games. Now, let's say that we have a home-away pattern called 2, 3, and 4. And each home-away pattern, 2, 3, and 4, for round 1, they all had away games. Now, this is virtually impossible, but disregarding the fact that it is impossible for now, we're just going to characterize A bracket open Q, comma S as 3. This is because we had no home games here in round 1, and the total number of away games was 3. And from those 2, from H bracket open Q, comma S, A bracket open Q, comma S, the minimum number is going to be 0. And we're going to calculate that score for all rounds that we have. And in, for instance, round 4, where we have 2 away matches and 1 home game, we can see that the minimum value of either an H or an A is 1. And using that information, we will be essentially creating a sort of an equation wherein we ensure that all home away tables just kind of adhere to that idea of having to have no 2 consecutive breaks, and at the same time not having an unequal number of A's and H's in one round. So here, let's say that we have 4 teams. Let's say we have 4 teams, and let's say that because we have 4 teams, we're going to label those teams A, B, C, D. And because this is a round robin sort of structure, we know that each of these teams are going to have to play another team, all of the other teams. So these boxes would essentially just be blank. But because there's a single round robin structure, let's kind of get rid of the scenarios that's mirrored. These 2 scenarios are mirrored, so we're going to kind of get rid of one of that. So we can see that in total, 6 matches are played. Let's say that for round 1, for round 1, A had a home match, B had a home match, C had an away match, D had an away match. Let's also assign imaginary scenarios for rounds 2 and 3. And let's say that this is the sort of equation that we get, this sort of table that we get. And from this, we can see that in round 1, the number of H home games was 2. Number of A away games was 2. So the minimum that we're going to have for round 1 is going to be 2. For round 2, that's also going to be the same because we have an equal number of home matches and away matches. For round 3, that's the same. Because we have the sigma function, and because n in this case is 4, we have 4 teams. n minus 1, we're adding the value that we got here for n minus 1 times. So we're going to add 2 3 times, and that's going to give us the value of 6. So this part of the equation gives us the value of 6, right? Now we need to calculate this scenario. Now Q here essentially denotes the set which contains teams that have the highest break. So what I mean by that is which teams have the highest number of break. In this case, all of these teams would be in set Q because they have an equal number of breaks. They all have 1 breaks, if we see that. They all have 1 breaks. So in this case, for Q, we're going to substitute the value 4. 4 multiplied by 4 minus 1, we get the value of 6.